In this calculus video, you will learn the basic notations and terminologies used in differentiation and integration, used in A-level, colleges, and universities. Let's start with this first notation, f of x instead of y. F of x is a function, while y is an equation. A function got tendencies to change values and shapes, while an equation presents a result and ends, with no intentions of changing shapes. For example, this will produce a straight line graph. As x changes value, this straight line will not change its shape. And to find the slope, it is change in y divide change in x. However, for a function, as x changes values, each point along the curve we have different slope, and to find the slope at each point along the curve is not as easy as a straight line graph. And the changing variable, for example, which is x here, will take integer values that exist on the number line towards the negative infinity and towards the positive infinity, including 0. Hence, in calculus, f of x is equal to y. Next, dy dx instead of changing y over changing x. That is, for a straight line graph, we usually use change in y over change in x, which is the rise divided by the run. And to find the slope, we are going to use this formula. However, consider a point on a curve, and this point can be choosing any point or anywhere along the curve. Let's start by choosing 2 points along the curve. You can see that x here is x1, while x2 now becomes x plus change in x, and y1 becomes f of x, while y2 becomes f x plus change in x. And with this development, our slope for a straight line graph will now change to this. At times, mathematicians represent change in x with h. In this comparison, we are trying to use what we know about a slope to obtain a slope that changes instantaneously along a curve. Here, we are trying to get the slope at a point and not at 2 points. And you can see that these 2 points will still give us a very large increment. However, we are looking for a very tiny increment towards this point. Hence, I will start to limit this triangle so small that the limit is running closer to 0 but not equal to 0. By so doing, I will now obtain dy dx. This is the concept of limit functions in pre-calculus. Next, this formula. Change in x can be represented as h and also can be represented as x plus h in bracket minus x, or as x plus change in x in bracket minus x. Your lecturer can decide to use any of them, because this minus this is the same as this. which also can be represented as h. But if you decide to use h, then this change in x will change to h. Just be consistent in your choice. Now you have known the difference between the slopes of a straight line and of a curve. Next, the y, the x, the xy, y prime, or y dot. Highways have many phrases for the same thing. This same highway structure can be called a rotary, or a roundabout, or a traffic circle, or a circular one-way. Similarly, in calculus, there are various notations for the derivative of a function representing the slope of the tangent line on a curve. Leibniz called it dy dx, while Lagrange called it y prime of x. Isaac Newton called it y dot, while Euler called it the xy. At times, it can be written as the xy. Representing different notations but meaning the same thing. To avoid confusion, be consistent in your notation. Next, differentiation also means derivatives and can be used interchangeably during a lecture. Next, with respect to. In calculus, we differentiate a function respecting two or more variables in that function. For example, I might decide to differentiate the life cycle of a virus with respect to time. Generally, we use dy dx. However, it can be dz dt, it can be dm dk, it can be dp dw. That is, if I'm given y is equal to 2x cubed, to find dy dp. Here, my answer is 0 because there is no p here for me to respect. And this will be explained in detail in subsequent videos. Next, general concepts to internalize when solving derivatives. Whenever you differentiate sine x, your answer is cos x. When you differentiate cos x, your answer is minus sine x. When you differentiate tan x, your answer is sec square s. And when you differentiate sec x, your answer is sec x tan x. When you differentiate cot x, your answer is minus cosec squared x. If you differentiate cosec x, your answer is minus cosec x cot x. Subsequently, if you integrate cos x, you are going to get sin x plus c. Later, I will explain the meaning of the c. If you integrate sin x, you are going to get minus cos x plus c. If you integrate sec squared x, you are going to get tan x plus c. If you integrate sec x tan x, you are going to get sec x plus c. While if you integrate cosec squared x, you are going to get minus cot x plus c. If you integrate cosec x cot x, you are going to get minus cosec x plus c. This you have to know by heart. As you play with calculus problems and solutions, this will become more familiar. The next concept is the differentiation of inverse trigonometric functions. you must familiarize yourself with these concepts. In addition, if you differentiate exponential x, you will get exponential x. If you differentiate in x, you're going to get 1 over x. Likewise, if you differentiate a to the power of x, you're going to get a to the power of x in a. Also, if you differentiate a to the power of minus x, you're going to get minus a to the power of minus x in a. You must also familiarize yourself with this concept. Similarly, it's important you familiarize yourself with basic trigonometric identity functions. That is, tan x is equal to sin x divided by cos x. Likewise, sec x is the same thing as 1 divided by cos x, and cosec x is 1 divided by sin x. Cot x is the same thing as cos x over sin x, and sin square x plus cos square x is 1. Likewise, cos square x plus 1 is cosec square x, and tan square x plus 1 is sec square x. The knowledge of this will save you a lot of pains when solving calculus and some mathematical problems. Likewise, the knowledge of basic exponentials and natural log functions is very important. That is, exponential in x is x, and in exponential x is also x. In x, it's the same thing as the natural log of x, which is the same as log x divide log exponential, but both must have the same base. Always remember that natural log will always neutralize exponential and vice versa. Likewise, familiarize yourself with all these concepts. Next, this is the general rule for differentiation. That is, if this 3 is n and 2 is a, then our dy dx is 6x squared according to the power rule. Next, the arrangement of a function will determine the method of differentiation. Here, this is the formula for product rule and quotient rule, respectively. And for chain rule, we usually apply this formula. Next, sum and difference in differentiation. This means I can take any 2 or 3 of these functions, then put it together to find the dy over dx. The result requires no method of differentiation. Such differentiation is known as sum and difference method, because each variable is separated with either a plus or a minus. Next, higher derivatives. For example, if we are given y is equal to 4x to the power of 5 to find dy dx. The dy dx usually have 1 here. However, we don't usually write it when it is only 1. The first differentiation is this. If we differentiate this again, we're going to have this. When we differentiate this again, we're going to have this. And when we differentiate it again, we're going to have this. This is what is called higher derivatives. And for the first derivatives, all this means the same thing. And for the second derivatives, this means the same thing. likewise the others. Next, in subsequent topics, we are going to learn when and how to use each of these methods of differentiation. Next, antiderivatives, which also mean integration, at times called inverse derivative or primitive function or primitive integral, and the symbol is usually denoted with an elongated x, and with the function written also we are going to write which variable are we giving respect to in that function. Next, the final answer in integration usually ends with a letter C, which simply means constant. The C takes care of constants that were discarded in differentiation. For example, in the differentiation of this function, you can see that 5 was discarded because there was no x attached to it. Hence, we are not going to give respect to the 5. However, integration got back the function, but you can see here that the 5 has been lost. Hence, integration have to include a C to take care of this or any other constant that was lost during differentiation. Next, this is the general rule for integration. That is, if I'm given this to integrate with respect to x, then our answer is going to be this according to the power rule of integration. Next, this is the formula when dealing with integration by parts in integration. When and how to use this formula is in a separate video. Consider this order when dealing with integration by parts. Consider the form of this partial fraction when dealing with rational functions in integration. Partial fraction will be covered in a separate video. Next, definite and indefinite integral. In definite integral, there have to be a lower number and also a higher number. That is, the b must be greater than a for this function to be valid. You just integrate and leave your answer with plus c. These formulas and notations are very important when dealing with integration of inverse trigonometric functions in calculus. To be able to solve some problems in calculus in integration, you have to familiarize yourself with this concept, and likewise these concepts and formulas. Next, in subsequent videos, we are going to learn how to use these methods of integration depending on the form of the function. Afterwards, we are going to look at applications of both integration and differentiation. This is calculus. In the next video, we are going to look at real-life applications of differentiation and integration. Afterwards, we are going to look at sum and difference method of differentiation. Then differentiation by the first principles. And we are going to start looking at other methods of differentiation in calculus. These are recommended video topics in differentiation. and also some suggested video topics in you can check out other recommended calculus videos. Including pre-calculus video topics. To locate all these videos, follow the link on the screen. I will see you in the next video.